Welcome to Quant Cop, Math Crimes Division, Episode 3. Today we ask the question, is standard deviation, or volatility, an unbiased risk measure? Simple answer is no. And there are at least two problems with it. One small and technical, which can be corrected, and one large, which at this point is never going to be corrected. So let's take a look. So if we do the math, the problem is you're squaring the deviations from the mean, right? Which means you give more weight to the large infrequent excursions. This ultimately overstates the level of volatility. So how do I correct for this? Well, we can use mean absolute deviation, right? We don't do we just take the absolute deviation from the mean, take that number and annualize that, and we can get a more accurate version of historical volatility or what's already happened, right? It's a residual number. The shortcut to that is, rather than going through the formula, you just take standard deviation multiplied by the square root of 2 over pi. Simple, right? Okay, so that's the minor technical correction you need to do, but like I said, this is not going to matter. It's not going to help you. So so by adjusting to mean absolute deviation, if we solve the problem, not even close. What we did is just rearrange deck chairs on the Titanic. We just corrected a bias in the calculation of the past. That's the real problem with standard deviation, or mean absolute deviation, lies ahead. The biggest issue with standard deviation or mean absolute deviation, and most of quant finance in general, is what's termed as the paradox of self-reference. What is that? Okay, so if we use standard deviation, or MAD, as a measurement device, we might be immune to the paradox if we just simply looked at it as a tool and say, okay, well, that's interesting, it's this. The problem is, in the action agents take after calculating this metric, they end up using standard deviation, or MAD, as both an input and a target. Their actions alter the process they're trying to predict. It's this circular reference that leads to an alteration of the underlying process and its associated statistical moments. From an information theory standpoint, what we're doing by acting on realized volatility to make decisions is we're creating signal or information out of noise or entropy, and vice versa, right? We're creating noise from signal. It's a cycle, right? From signal to noise to signal to noise. So signal gets recognized and acted upon, which leads to self-reinforcing feedback until it becomes almost pure signal and little noise. So at this point, some random catalyst occurs, and then the process perverts, right? So then we witness self-correcting feedback in the opposite direction, right? Where noise increases as signal erodes, right? This cycle is perpetual, right? You go from little signal to pure signal, to less signal to pure noise. Constantly cycle in this way because markets, as discounting mechanisms, are always looking for signal and acting upon those signals. So it ultimately means that everyone using historical volatility as an active risk management device will be, by necessity, maximally exposed at the top and minimally exposed at the bottom of every cycle. It's essentially driving a car through the rearview mirror. As long as we're going straight and there's no turns, there's no problems. But once you have a turn, you hit a tree and you fly through the windshield and you're dead, right? These models are reactive. They're not predictive. They're statistical in the sense that they look at the past and then they say, okay, the future should look like the past, so that's how we're going to behave. And these models are ubiquitous. They're everywhere. Value at risk, risk parity, low vol control programs, CTA position sizing. Everybody that trades a portfolio that uses some quantitative risk modeling is going to use 1 over sigma as some sort of either position weighting or vol control level. It's just the nature of the game. So here's an example. Here's vol control programs. This goes back to, I think, 2006. They're always exposed right before markets go south, Now, they could be right for a long period of time because trends occur, but they're systematically fully exposed at the top and minimally exposed at the bottom. Here's another one, risk parity. Same thing. Look at how exposed they were before Volmageddon in 2018, and then again into March 2020. It's just the nature of this reflexive process of using standard deviation of volatility as a risk measurement device. You're altering this process because it's a complex adaptive system. It's not a linear stochastic system. You got to understand that. The models you're using are not going to be ineffective in a nonlinear adaptive and evolutionary environment. So, if you haven't noticed yet, in the real world, quant finance is an Ouroboros. It's essentially a snake eating its own tail. Its tools always fail in the limits mathematically, where they're needed the most. The only time you really need a model is when things go badly, right? So these models fail exactly when you need them the most. The rest of the time, it appears to work fine, and it actually encourages this feedback mechanism in both directions. But you could have used astrology in the same thing. I mean, you would have got the same results, right? So you got to always be cognizant of how your perceptions, and more importantly, your actions, are altering the environment you're operating in. Knowing the residual risks, such as standard deviation or MAD, it's not enough information when dealing in the domain of uncertainty. The future. The future is always uncertain. We don't know the distribution of the future. We have to make inferences, probabilistic inferences. That's why using residual or historical or backward-looking linear stochastic modeling is just going to put you in the wrong place at the wrong time. Till next time, shaka and aloha.